I talk about the manufacturing system. So manufacturing system is the step-by-step method. When we are starting the manufacturing process, the marketing section need to identify the customer needs, and then the designers interpret the drawing, and also prepare the design brief, and the engineer convert the product, the drawing to the manufacturing information. Manufacturing section convert the information to product, and marketing interpret the revised product for the selling off to the customer. So those are the typical procedure for the manufacturing process. So when you do the manufacturing process, go step by step. Marketing, design, engineering, and manufacturing are the 4 areas. Marketing, design, engineering, and manufacturing are 4 areas. Normally, there should be the series. But do the marketing first, and then do the design, do the engineering, do the manufacturing. So this one is simpler. But the thing is, it can take a long time. Another thing is, if you are running the one by one, so one is some quality logo or inappropriate, you have to restart from it up back to the first position. So this is why the Western countries usually they use the CDS production. They do the step by step. One step complete and start another step. So in the Asia, Japanese manufacturing system is different from the Western approach. Japanese system they do that as much as parallel. Parallel means that while doing the marketing, they are making the overlapping. During partially do the marketing, before marketing is complete, design people start. So this means that marketing people give regular advice to design people produce the thing. In the meantime, when the design is completed into the halfway, and then the engineer starts doing the details of design. So the engineer and the marketing section, the design section, engineer section, they are the interaction. They make the communication and they make the product. So by doing this one, Japanese systems they can cut the die. The die is safe, and they can cut the die. But this is the one advantage is that you can reduce the manufacturing die. But disadvantage is that sometimes complete information can be misinterpreted. Because before finishing acquiring the complete information, you cannot justify that this one is totally the right information. So sometimes people today the quality information people start making a design like this. So they make the design, they make the repeat, they make the change over like by this way they run. But their system is can see the die. And also they can interactive response. So all the things of market situation can be changed out from time to time. So when the marketing information change, and the engineering, manufacturing need to be changed immediately. So we cannot wait for the long time to get the complete information because of that. You see that the things sometimes are better way the other way. So some change are the significant. Before changing to the significant change, you can see that early sign of changing. A little change are happening, and then go to the major change. So on the at the stage of the little change are identified as product, and before reaching to the major change, they are making the appropriate preparation. So this is ways that we use early monitoring and the early identification system they utilize. So by this way before that you haven't produced a lot of the products, you can identify the market situation. You can update your market regularly, and you can make the appropriate change. So that kind of two manufacturing systems I will give the note for you. Now that we can compare the Western approach and the Japanese approach. Western approach is normally they start the marketing, they do it one by one, and then design, engineering, manufacturing. Japanese system is they used to make the same time. Marketing as a main they design and engineering start and manufacturing start. So by the way they stay the time. So, but the thing is that Western approach sometimes is both systems called both a good point and a weak point. Although Japanese do the same, sometimes they can make a misinterpretation because of before acquiring the complete information, they start design, so they have to repeat the design. This is the thing. But this why is a serious system means that sometimes a change happens, so at the time you notice that will be right. So Now that we can compare the activity from concept to the product launch, so we can make the engineering activities a comparison. The Japanese system is a early time they make a lot of engineering input, and later time they reduce the engineering input. Whereas system is early time they don't make the too much engineering, after that they are input and more engineering. So this is the Japan and this is Western. So this is for the from the concept to the product launch, so we can make the comparison of the engineering activity. So in this case, the people are depending on the different profession, so they make the different interpretation. Especially when on the one product, the view will be different. Marketing session describe one thing, engineer see another thing, product production session see another thing, and the customer one is another thing. So those things, all the things should be appropriate. So marketing description, engineer description, production system that they are believe a customer requirements, and all the things are, although they may not be the same, but they should be appropriate. This is the two system. The Western system is we use they do that the things are serious. Firstly, they take the marketing section, have that information, and then pass through design section, make the design procedure, and engineering section, make the implementation and manufacturing sections are produced. The Japanese system is marketing, design, engineering, manufacturing, and they are overlapping. So a lot of the engineering effort is inputted by the Japanese at beginning time, but Western systems they come at the later time. So how the marketing describe it, how the engineering saw it, what production performed, what the customer wanted, those are the important aspects. So in this case, when the engineering changes are done very big in the process, so they may face a constraint. But for the Japanese system, all the marketing, engineering, production provide the effort in the design concurrently, so that they making it at the same time. So by doing the same time, they design and produce a new product. So this system also got an advantage and a disadvantage. Advantage means that we can reduce the product time to market. So when the market when the product is started, they can produce in a short time and supply to the market. So this is why in the new product coming, so people they want to buy a new product. Now you see that the iPhone coming, people want to acquire the iPhone. At the time, the Japanese they produce and sell to the market. So the people, so they can easily get the market on it. People can buy. So this is why every new thing coming, they can produce, they put to the market by this way. So this is reduces the product time to market and also reduce the engineering cost. Engineering cost means that by doing the same time, you can reduce the engineering cost. And better responses to the market needs. As soon as the market requires, they can change the model, one model to another model very in short time. But this system also got a disadvantage. So that it can increase the overhead. Overhead means that you are running it one by one. In this case, for example, once a product engineer, marketing manager, they make the thing, design people do, engineering do, manufacturing do, so they make all the things. So this is the only one thing. One thing can manage all, no? One the general manager require. But if you run it every day in parallel, this means that you need a more people to run too. So more people to do, so they are more better communication. And another thing is that you are making the thing is so you need a more facilities. Facility means that all the same station, you need all marketing session, engineering session, another place also one marketing, engineering, so that everything that we have to do in the join in the parallel. So this means that by doing the more people working, so it can increase the more overhead. So the overhead also contributes the cost of the product. So in the way you make the design, raw material, and the material manufacturing process, they are also provided by the overhead. Overhead means the design charge, administration charge, everything also included in the design process. So this is for the one kind of the disadvantage. And cost of the relocation. So in this case, the cost of relocation means that this system, people need to move from one place to another place to have to work in the same one thing. So this means the cost of relocation is also increased. And also it can face the cultural resistance, and also the appropriate application can happen because of the without getting the complete information, they can have face the appropriate application. So those are the we find in the Japanese system to make the appropriate criteria. So as a state, the marketing stage service they call it the information and design. They review the market information and they have to judge whether this should be the appropriate or not. Should be design or can't design. Engineering section also they interpret the design whether it is practically possible or not. And manufacturing section they make the whether it is economical production or not. They have to the time and the product the cost and effect, the analysis they need to be done. So because of this one, that will be the key question. So the first thing is that should we launch this project or not? So depending on the kind of the technical difficulty or the possible profit or possible complication, you need to judge whether this project should be started or not. So in this case, so we have to review the market analysis report, preliminary finding, requirement feasibility study, manufacturing assessment. Those are important for the before you decide and these are starting on the project. And after that, is it feasible to start the project, and then you have to judge whether you should go along with this project or not. So in this case, you have to review the approach, design specification, pre-introduction requirement, the prototype requirement, all that they have to be done. So this is mean that when you are developing one new product, so firstly that you do the introductory product and they put into the market. So they review the market response. If the market is going all right, they can get the market welcome this product, and then will be a lot of the potential customer, and then they proceed at this phase. So this is why the market survey is important for the manufacturing process. Key criteria means case 0 is a key question. Should we launch this project? So in this case, analysis to be focused on the market analysis report, preliminary funding requirement, manufacturing assessment. They have to be studied. And then should we proceed with the design strategy? So in this case, you have to analyze the approach of product specification, pre-introduction requirement, prototype manufacturability. So those things have to be assessed to justify whether you should start the project or whether you proceed with the project. So this is what this days I'm talking about the project system, manufacturing project. So how the factors are influencing the project, what are the disadvantages, and then what the factors to be review to assess the project. And then after that we will model the project. So modeling the project is a detailed model. So there may be when you are modeling the project, in this case we have to start with the sub-project. So project is a big project. So big projects you have to be divided into the sub-project. So the mini projects are major, they are combined with you call the major project. So in this case sub-project analysis can be the numerical analysis. Numerical analysis means the data analysis, what to be function, time analysis, material analysis, those things have to be done. And also the project project performance the custom experience are also important. And then those are inputs to the from the outside the factor, they make the input and they start the project and they produce the feedback. And so these things are that they are circulating and these are complete the project. So now this is all the general model of the project management. First modeling the project system, GD model. So the general approach to planning involves starting with the raster overview and conducting the revision of the true project. So then we the project is start with the sub-project. The numerical analysis, experience, project owner, customer, they are involved in this project, and they input energy, performance, and output. So output is need to be approved. So they will pass it through the approval process. So any things are refinement can also revision need to be done for approval, and then they will go back to the the system. So they do the project and go to output and refine, approve it, and go back to the system, modification, do again. So this is for the planning sequence. So planning sequence means that everything you make the plan, so every step needs to be refined and approved before that you reach the final activity. So then we have to arrange the activity. Activity can be the sequence, activity sequence. So then you need to draw the activity. For example, day 1, day 2, day 3. In this case, you have to put the activity like this, activity 2. So this activity 2 you can also need to record it in the data. So this is for the activity and the finish date. So for example, activity is study activity. So we start from the 2nd of February 2010, and this one go and end. So end as 2nd of November 2010. So this is for the activity sequence, study and the finishing. So this kind of activity project plan, you also need to provide it in a graphical form. So this is for the project plan and the graphical form. Project plan and the graphical form. So graphical form is first things before you start the project. So then will be the project can be any project. So material based project or the research project. So regarding the research project, firstly you have to do the literature review. Literature review means that if you are doing any design, so you need to refer the appropriate reference book formula method. We have to refer and you have to call it an book. For example, you want to design for the motor control system. So in this case, you need to call it the motor. You need to go to the control. You need to go to the system, protection. Those references you have to compare. So this is the literature review. And then you have to analyze the task. So how to design the motor. So how far with the motor side, motor current, and appropriate starter, appropriate construction. Those things have to be you have to analyze. And also you have to review the questionnaires. Questionnaires means that you have to make the question. If the motor is overcurrent, what will you do? And if the motor is a no load, what will you do? Those things have to be analyzed. And also the questionnaires, you have to make the appropriate answer. Answer means that if the motor is high power, so you have to provide the appropriate circuit breaker. So where you got the circuit breaker, in this case you have to outline. So you can purchase or you have to install from the remote from the other products. Those they have to do. And then analyze the result. So then you make that thing, you work it, and then you test the result, and then you have to analyze the result. And after finish you have to put the write up. Write up means at the end you have to write down the project report. So that when you are doing the project, so you can start with the project. After at the end you have to write down the project report. Project report means that the whole procedure, what you do, what the function, how you coordinate work, what material you utilize, what technology you use, what the formula you apply, so then you write, and any difficulty, any suggestion, it has to be included with the project. And then you have to hand in the date. So this is for the typical procedure for the project plan. So project plan means that you can either do the material-based project or the paper-based project. So those project plan and time to time the function has to be included. So this is for the project plan. Then you can see the carry of the literature review, arrange the task. Every one cost means number of days or number of months. So number of days or number of weeks, this is the cost indicate. Arrange the prepare the questionnaire, review the questionnaire, deliver the questionnaire, and analyze the result, write up, and hand in date. So these are the project packet. So those are project steps. So in this case, you make the project schedule. Before you make the project, you need to schedule the project. So in this case, there will be a forward schedule and a backward schedule. Forward schedule means start with the activity at a given day and follow and the forward on the die. So start with the activity and then you have to get forward the die. And backward schedule means in this case you need to finish the project by the starting day. In this case you better do the backward schedule. So at the time of completion you have to go back the activity. So that in this case you can make the time allocation. Because by doing the backward schedule, any time leak, any less time or any very rush time you can identify. Sometimes the project is too big, but the time schedule is too narrow. In this case you have to change appropriately. So depending on the difficulty of the project, so you better should do the backward schedule. Backward schedule means that you can avoid. Sometimes what happens at the early time of the project, people spend a lot of time. They spend a lot of time so that they do, but at that time that they don't have the time. So it can happen like this. Even the university, the students, the last minute, they got the one semester, the 4 months. 4 months, 1 month, 2 months, they don't do. And then before the test, or about 2 or 3 weeks, 2 days before, they make it very rough. It can happen like this. So happen like this, every day finish, so they sometimes not completed. It can happen like this. So this is time the things in there. The forward schedule is good for the if you got a lot of time, and your quality is time requirement is less important than the quality. Quality is more important than the time requirement. In this case, forward schedule is good. So especially the research project. But for that, you need to complete in time. In this case, you should do the backward schedule. Forward schedule means start the activities at a given date and follow then the forward on time. Schedule means that look at the time by which the project is needed to be completed and work out the. So in this case, activity and date allocation chart you need to design. So this is we call the Gantt chart. Gantt chart means that time and activity they are drawn by on the chart by arrow. So for example, here you see that activity can be a literature review, analyze the task, prepare the questionnaire. Those things are tasks. So those things tasks you have to draw the time allocation on the table. So this is we call the Gantt chart. So this way you say with the February 1, 15, 28. So this is the date, and March the date, and the April date. So that when you are doing the literature review, so you plan to do the literature review in the February, so you can draw it like this. So between February 1 to 28, you are doing the literature review. And analyze the task. So that you also from the March 1 to 131, you are analyzing the task. And as March, April 1 to 30, you are prepare the question. Those things are the Gantt chart. So when we are doing your project, it is a good idea to also to include the Gantt chart. So this is for so when you are in the industries where we are using the managing the project, the Gantt charts are the compulsory. So by doing the Gantt chart, you can know the time allocation. Time allocation means which time is doing the which day, and then so you can know whether it is possible or not, whether you need more time or not. Those things have to be you can revise. So this Gantt chart is the number of activities and resources is low, and environment is fairly static, and the periods are relatively long, day weeks rather than the hour. So these Gantt charts are the most important and more appropriate for the simple project. So simple project means the number of activities and resources is low, environment is fairly static, the periods are relatively long, day and weeks rather than the hour. So those are the Gantt charts. But Gantt chart got a better point and a good point and a limitation. The good point means that they are simple to draw and read, good for the static environment. So static environment means that if you don't change too much, Gantt chart is better. But you want to change the activity during the project time, you need to update it. You need to update. You need to change the activity. In this case, Gantt charts are not appropriate. So in this case, you have to use planning sequence chart and arrow on the node diagram. Need to be draw. Advantage is a good point is that simple to draw and read, good for the static environment. and very widely used, the basis of the graphical interface for the most busy software. So the Gantt chart are good for a similar project. If the number of activities and the resources is low, and the environment is fairly static, and the periods are literally long, days and weeks rather than hours, so you should use the Gantt chart. But Gantt chart got a limitation. The difficult to the update, where there are the many changes, and chart can quickly become obsolete and therefore discredited. And does not equate the time with the cost, and does not help in the optimizing resources allocation. So those are the good point and the limitation of the Gantt chart. So because of this one, if you want to change the activities, it can frequently get changing. In this case, you should utilize the activity on the arrow diagram. Arrow means activity, and node means method. So method activity of the node is a target. Arrow means the activity. So this arrow and the node diagram are utilized to for the planning sequence. Planning sequence, so appropriate time you can utilize. And another thing is that you can also determine the critical path analysis. Critical path analysis means that this you make the starting changes. Starting path is that you can eliminate your bypass, you can modify. That part you can also determine by the critical path analysis diagram. Now I will give you the arrow diagram. Arrow diagram, so activity or arrow diagram. Node is the activity or node. This is the one. It's the arrows of from state 1 to state 2. The A activity happen. So we can planning sequence means that we can identify the activity, determine the sequence, and estimate the time for the each. So this is for the good for using the activity or an arrow diagram. For example, activity 1. So from the 1 to A is A activity, you put the 5 days. And from the 2, node 2, and you start the activity B, that will be the 2 days. And finally, node with the 3. So this is for this sequence. In the meantime, sometimes you need to do the activity in parallel. For example, from the collision 1, you start the activity A. For the 2 days. And you reach that 5-2, and then you have to do the activity B, activity B, and activity C, and activity D, and simultaneously. So by doing that activity, you reach the collision 3, collision 4, and the collision 5 respectively. So this means that within 1 to 2 is a 2 days, but the 2 to 3, 2 to 4, and 2 to 5. 2 to 3 is the activity B, 2 to 4 is the activity C, 2 to 5 is the activity D. They are to be done simultaneously at the same day. So this is you can draw the graph like this. And similarly, you can after this activity 3, 4, 5, they continue. So the activity 3 is go to the activities 7. So this is the E. And activity 4 to the 7 to F. And the activity 5 to 7, so this is G. And then go to the activity 8, so action will be H. You can also draw like this. So this means that all activities are doing concurrently, and after they all are performed, all the parameters are completed, you can proceed the final activity 8. So this is one way that you can also draw the graph chart. In the meantime, the standard activity can be like this. Activity E, and started and they both reach the activity 10. 10 point and the E and F are same time, and after that they go to another G and the H. We can also do sometimes you can also show the interaction. Interaction means the activity J started for the 11 point and continue to activity F. And also the activity K go to activity 12 and go to the activity M. So from the 11 to 12 you do another activity, so P. So that kind of also graph. This means that you do the activity J and proceed to the activity N, and K to N. Between the 11 to 12 nodes, the activity P is to be performed. So this is for the chart. So those things are the activity on the arrow diagram. So you can draw the diagram as you like. The day you can arrange the task. So this is the most flexible than the Gantt chart. So that when you are planning the project, you have to utilize that kind of thing. So this is for the activity on the arrow. Another one we use is analyzing the memoir of the critical path analysis. So you have to know, this note you have to indicate event, earliest event time, and latest. So those three things you have to record. So every note is a step to complete the process. Step to complete the project, for example, you are designing the swivel system. First, you test in all equipment. This is one node. And then you have to use dismantling the equipment. This is second node. And you have to reassemble it. This is the third node. So there are 3 days. You remove the all equipment. This is the phase 1. And testing phase 2. And reassembling phase 3. And retesting phase 4. So this is 4 phase. The 4 phase is that you have to use the activity. This is the kind of activity. This activity means this is the testing, dismantling, testing, reassembling, those things. So this is the activity. Here will be this is earliest time. So this is the latest time. On the same note, you have to write down. So this is the earliest event time and the latest event time. Earliest event time and latest event time. On the second, this way how we the activity, you have to write down the activity, and then you have to record the earliest event time and the latest event time for each quarter. So this is for the chart. So that when you design the chart, we have to use the kind of the circle. The kind of circle, and then you have to show the activities. Doing the activities are 10. So for example, you can write activity 10 means that you can remove in the circuit. So this is called dismantling. This is activity 10, activity code, and activity. So activity code is 10, so this is a dismantling. Activity 20 means this is testing. For example, you made the activity code. So this activity code will be included in the node. So how to code so that, for example, this one will do the activity here. So activity 10. Start from the day 0. So earliest starting time is at day 0. You get also the latest starting time also the days are 0. And then so you can start at A. A means the A activity. So this means that then activity 10. So this is the activity 20. Activity 20 means testing. So then we use the earliest starting time will be 5, later is a 5. So then we use that you can go the arrow chart. So this chart is the earliest starting time, latest starting time, and the activity can be recorded by this way. So this becomes the activity label or direction. So in the project system, we used to draw this kind of chart to make the interpret the project. For example, you see the activity 10. So this node, so activity 10, earliest starting time 0, latest starting time is 0. And after that, this one is at A, action. So they go reach to the activity 20. So this is the earliest starting time 5, later is a 5, and then you go to the action B. Action B, so this one go to this chart 30. So earliest time we use so between this 3 days, so then we use for example, this one is a 5, so the 0 plus 5, so 5 is 5 here. And then this is this day is 5, and the duration is 3. So the 5 plus 3, then we use 8, and this also 8. And then this one is activity C. The duration is 4. So the 5 plus 4, so this will be 9. And also 9. So then we will so activity 50. And then you can go to the activity D. So that way duration also 5. So you see that the final activities are 50. So the 5 plus 5 will be 10. So this one 10. After that, this one is the use end with the activity E. So duration is 6. So 8 plus 6, the final activity will be 14. So this one activity will be the 30, and the 40, and the 60. And similarly, this one go to here is for the activity at the 7, so the 9 plus 7, so then will be 16. So 16 means you see here, this one also the activity start is a G and a 5. So 4 will be the this side. So this is the 8 plus 3 is a 14, 9 plus 7 will be the 16, 10 plus 5 is a 15. So there will be the 3 things that can happen. 8 plus 6, that will be 14 days. 9 plus 7, that will be the 16 days. And there's a 10 plus 5, that will be the 15 days. So they can be the 16 or 14 or 15 or 15. 3 things happen. So in this case, times are different because here, this look 30 to the activity E, so we take the 6 days. So the 8 plus 6 will be the 14. Here 9 plus 7 will be the 16, 10 plus 5 will be the 15. So in this case, earliest one is the 14, and later one is 16. So here we write down earlier one 14 and later one 16. So this way that you can write down like this. So these two guys are not always at the face. Only one arrow that will be the earlier and the latest time will be at the face. Okay, because of that, only one arrow. But here is this one. 3 arrows are coming in. So 3 arrows are coming in, so that their time will be different. So you have to indicate the earliest time and the latest time. Earlier time, this is the 8 plus 6 will be the 14, and 9 plus 6 will be 16, and 10 plus 5 will be the 15. So the 16, 15, and the 14. So 14 is at the last one, the least value, and the 16 is the biggest value. 14 is the smallest value, and 16 is the biggest value, so you have to write down 14 and the 16. And after that, you go to the activity H, we take the 8 days. So that will be finally you reach the 70. So the 14 plus 8, final, the earliest completion time will be 22, and latest completion time will be 24. So by this way that you can determine. Depending on the activity, you can determine the earliest completion time and the latest completion time. So this is you can know the allowance. What time this function can be finished in the earliest, and what should be the final time. So this is the things that we can solve. When there are more than one activities meet at the starting supply, the earliest completion and latest completion time can be determined as above. So by this way that you can determine the earliest and latest completion time. Only one arrow is the only earliest and latest is the same, but the several arrows are meeting, then we use a different. Start from the 10:00:A5, these are 25:5. So there's a B activity, it's coming 3. So there will be 30. So we need to complete the earlier time 8, but we don't know that this side, later side. And similarly, the activity C. So C is the 4 days. So this one will be activity 40. So earlier time is 9, later time is 9. And also this one from here to here is another activity. So this is D, the 5 days, the 50, and the 10, and the 11. Then we don't know this one. And then this one, they are going to here. Go to this one. So in this case, we want to finish the 60 and 16, earlier time 16, later time 16. And then we go to the activity N. So this one is the activity G, this is the 5 days, and this is for the F, the 7 days, the E will be the 6 days. The final activity will be the 70. 70, so we want to finish everything by the 24. 24, and this time will be 8. So you see that this one, this is graph. This means that we can start as a time, starting time is 0. And at another point, that will be the 20.55. And then final completion time is must complete by the 24, and this is before prior the final state. The state must at the 50 must be complete by 15. So there are the 3 activities. So activity 30, 40, and 50. You need to calculate the time for the activity 30, 50, and 40. So how will you calculate? You have to make the back one. Back one means that 24 minus 8 is a 16. Is that alright? And then you go to here. 16 minus 8. So this is the 8. According to this graph, 16 minus 8 is the 8. And this one, 16 minus 7. 16 minus 7 is equal to also the 9. Here, 16 minus 5 is 11. So 16 minus 5 is 11. So this is the 3 things that you can go. So that how you put the time here. So this means that 16 minus 6 is 16 minus 6 is equal to 8. 16 minus 6 equal to this is 10. So this becomes 16 minus 6 is 10. This one will be 16 minus 7 will be 9. This is 16 minus 5 will be 11. So you can now put here. So 16 minus 6 is 10. So this point is the 10 point. This point you can put it 10. Okay, so 16 minus 9 this is alright. And here is 16 minus 6 is 11. So this one will be 11. So this is for the backward schedule. So backward schedule and the forward schedule. So in this case, you see the forward schedule. This is alright. This is 5 plus 4 is 9. But here is the forward schedule is 5, 8, but backward schedule is 10. So there will be the two different times. So also here is the 5 plus 5 is 10, but this one 16 minus 5 will be 11. So this is the backward time will be 11. So this is for the by this way that you can recalculate the allocated time at the starting stage. So this is backward schedule. So this is for example the backward schedule.